Hello, hi dear students, welcome to my channel Maths with Panindra. In this video, we are going to discuss increasing decreasing functions by using derivatives. In the last class, we discussed about increasing, decreasing and strictly increasing, strictly decreasing. Show that the function is strictly decreasing, show that the function is strictly increasing. Based on the concepts and problems we discussed, now in this class we are going to discuss the definition as well as some examples regarding increasing decreasing functions by using the derivatives. See here the function, the first point, the function f of x is said to be increasing in either open interval of a comma b or closed interval of a comma b. The x value belongs to this interval. Whatever you want to take, either it is open and closed open, we can like this. Increasing in open interval of a comma b, then f dash of x is greater than or equal to 0 for all x belongs to open interval of a comma b. You remember that. So the function f of x is said to be increasing. Then f dash of x is greater than or equal to 0 for all x belongs to open interval of a comma b. Suppose if you are taking here closed interval of a comma b, here also for all x belongs to closed interval of a comma b. Now we are going to define strictly increasing. The function f of x is said to be strictly increasing in open interval of a comma b, then f dash of x is greater than 0 whenever strictly increasing. Only greater than equal to the greater than 0 only will come. You remember that, dear students? Only greater than will come for all x belongs to open interval of a comma b. Now decreasing and strictly decreasing. The function f of x is said to be decreasing in open interval of a comma b, then f dash of x is less than or equal to 0 for all x belongs to open interval of a comma b. Similarly, strictly decreasing. The function f of x is said to be strictly decreasing in open interval of a comma b, then f dash of x is less than 0 for all x belongs to open interval of a comma b. These are the definitions regarding increasing decreasing functions by using the derivatives. We know that f of x is a function means f dash of x is greater than 0. F dash of x is greater than 0, increasing. F dash of x means it is a derivative of the function. We will take one example regarding increasing and decreasing. We will discuss the examples. Find the intervals on which f of x equal to x square minus 3x plus 8 is strictly increasing or strictly decreasing. They are asking to find in which interval the function is strictly increasing, in which interval the function is strictly decreasing. They are asking. See, first to calculate the intervals, we need to calculate the derivative of the function. So first given function f of x is equal to x square minus 3x plus 8. So now differentiate with respect to x, dw or dx. Differentiate with respect to x. F of x derivative is f dash of x, d by dx of x square 2x minus 3 constant, d by dx of x is 1, so 3 into 1 is 3, plus 8 constant is 0. So f dash of x value is 2x minus 3. Now, in which interval the function is strictly increasing? In that first question, f of x is strictly increasing. Strictly increasing. Then f dash of x is greater than 0. What is f dash of x? 2x minus 3. That is 2x minus 3 is greater than 0. That implies 2x is greater than 3. Minus 3 I am taking RHS sign. So that implies x is greater than 3 by 2. We discussed in the earlier classes in functions, x is greater than a means, see here, this is the real number line, this is 0, this is 3 by 2, this is infinity, this is minus infinity. Whenever x is greater than 3 by 2, x is greater than a means the value of x belongs to open interval of a to infinity. So x is greater than 3 by 2 means from here to here it will come. So x is greater than 3 by 2, that implies that x belongs to open interval of 3 by 2 comma infinity. In this interval the function f of x is strictly increasing. F of x is increasing in this interval. So now come to the second one. F of x is strictly decreasing. Strictly decreasing. Then f dash of x is less than 0. That is, f dash of x means 2x minus 3 is less than 0. 2x is less than 3, that implies x is less than 3 by 2. In the real number line, this is 0, this is 3 by 2, this is infinity, this is minus infinity. So x is less than 3 by 2, that means from here to here, this information will come. So from here to here, from here to here it is increasing, from here to here it is decreasing. So that implies x belongs to open interval of minus infinity comma 3 by 2. In this interval the function is decreasing, strictly decreasing. In this interval it is increasing. So conclusion step, therefore f of x is, we can write even increasing itself, strictly increasing, strictly increasing. In open interval of 3 by 2 comma infinity, and f of x is strictly decreasing, strictly decreasing in open interval of minus infinity comma 3 by 2. Sir, how to know this is 3 by 2 to infinity? In the earlier classes I said that here, these are the important points, dear students. When x is greater than a, that implies that x belongs to open interval of a to infinity. Keep in mind these points. When x is less than a, that implies x is belongs to open interval of minus infinity to a. Suppose if it is x is greater than or equal to a, that implies x belongs to closed interval of a comma infinity. If it is x is less than or equal to a, that implies x belongs to open minus infinity to closed a. These are the important things you remember. In the coming questions, another formula set also I am going to give you. So we will move to the next questions. The next question. Find the intervals on which the function f of x equal to x cube plus 5x square minus 8x plus 1 is a strictly increasing function. They are asking to find the intervals for the strictly increasing function. So first you have to consider the function and find the derivative. After that you can apply the formula. So first given function f of x is equal to x cube plus 5x square minus 8x plus 1. Differentiate with respect to x. So f dash of x is equal to x cube derivative is 3x square. 5x square derivative is 5 into x square derivative is 2x. Minus 8 into x derivative is 1 and constant derivative is 0. So f dash of x is equal to 3x square plus 10x minus 8. So here 3x square plus 10x minus 8. Whenever quadratic expression we got it, you need to write the expression in terms of x minus alpha into x minus beta. Sir, why to convert in this form? To find the intervals. Why? Because whenever you got this form of x minus alpha and x minus beta, it is easy to calculate the intervals by using domain concept in the functions. That is the reason. Here I am simplifying. If you find out the factors, 3 into minus 8 is minus 24. So 10 can be written as 12 minus 2. So 3x square plus 12x minus 2x minus 8. From these two take common 3x into x plus 4 minus 2 take common x plus 4. So positive value x plus 4 we write first, take common x plus 4 into 3x minus 2. But I want to write in the form of x minus alpha and x minus beta. So x plus 4 can be written as x minus of minus 4. Is it possible to write or not? We can. After that here also 3 take common into x minus 2 by 3. So 3 we can take this side. It will become 3 into x minus of minus 4 into x minus 2 by 3. This is the value of f dash of x. Even this is also f dash of x. But according to convenience, we are writing in that way. Now, they are asking to calculate intervals on this now. Only they are asking strictly increasing. The function f of x is strictly increasing. Then f dash of x is equal to, f dash of x is greater than 0. What is f dash of x? This value only. So that is 3 into x minus of minus 4 into x minus 2 by 3 is greater than 0. The 3 value we can take this side, 0 by 3 is 0. So now x minus of minus 4 into x minus 2 by 3 is greater than 0. After getting up this step, go to the functions domain formulae. Clearly I am giving here formula. Keep in mind, dear students. Whenever x minus alpha into x minus beta is greater than 0, when alpha is less than beta, the value of x belongs to open interval of minus infinity to alpha union beta to infinity. Otherwise, they can write as x is less than alpha or x is greater than beta. Even both are same. But you have to write in this way. This is the right one. So alpha value is what? Minus 4. Beta value is 2 by 3. When compared with 2 by 3, minus 4 is obviously less than. So alpha is less than beta is also satisfied. So now x belongs to which interval? Open interval of minus infinity to alpha. Alpha value is minus 4. Union beta to infinity. Beta value is what? 2 by 3 to infinity. So in this interval, the function is strictly increasing. So in this interval, f of x is strictly increasing. That are not asking decreasing, so you can leave it here. This is one of the important questions which asked in the public examination for 4 marks. Dear students, keep in mind. We will move to the next question now. The next question. Find the intervals on which the function f of x equal to x power x, where x is greater than 0, is increasing, decreasing. In the examination, in board exams, if you were given increasing, decreasing means you can consider as strictly increasing and decreasing. So, given function is f of x equal to x power x, differentiate with respect to x. F dash of x is equal to d by dx of x power x. Sir, why sir you are writing only for particular problem d by dx of x power x? In the differentiation concept, we discussed that whenever the function is of the form f of x whole power g of x, taking log on both sides and doing it. So, this is one of the standard formula. D by dx of the derivative of the function d by dx of x power x is equal to x power x into 1 plus log x. Log x means what? Log x to the base e. You have to remember this, friends. The derivative of the function x power x is always x power x into 1 plus log x to the base e. Log x means base is always e. That is called common logarithm. Sorry, natural logarithm. So now f dash of x is equal to x power x into 1 plus log x to the base e. Now come to intervals, increasing, decreasing. Here already increasing is there now. So here decreasing I am writing. The function f of x is decreasing. Then f dash of x is less than 0. That means this value, that is x power x into 1 plus log x to the base e is less than 0. That x power x value is always x is greater than 0 means this is positive. So it should not be less than 0. Obviously what will be less than 0? 1 plus log x to the base e. Value is less than 0. So 1 we are taking this side. Log x to the base e is less than minus 1. Plus 1 we are taking this side. It will become minus 1. Based on the logarithm properties, log x to the base e is less than 1. If you remove log here, this e power minus 1 will come. So x is less than e power minus 1 based on the definition of logarithm. See here, a power x is equal to n if and only if x is equal to log n to the base a. So if you remove log here, n is equal to a power x. Based on the definition of logarithm, we will write like this. When here equal symbol is there, here inequality is there. That is the only difference. The difference is by definition of logarithm, log x to the base is less than minus 1. So if you want to write x value, x is equal to e power minus 1. What is the meaning of e power minus 1? 1 by e. So x is less than 1 by e. I already said that in the previous class, in the previous question. X is less than a, that implies that x is belongs to minus infinity to a. So therefore x belongs to minus infinity to 1 by e. Here you remember that, dear students, x belongs to minus infinity to 1 by e. But you have to remember x is greater than 0 they mentioned. So minus infinity to 1 by e here. X is greater than 0 means from here to here only will come up. It won't come this value. So instead of coming here, only you can take, that is, since x is greater than 0, so x belongs to only 0 to 1 by e. In this interval, the function is decreasing. So x is decreasing, f of x is decreasing, in open interval of 0 comma 1 by e. Now comes the increasing. So f dash of x is greater than 0. What is f dash of x? This value. X power x 1 plus log x to the base e is greater than 0. Obviously x is greater than 0. So 1 plus log x to the base e is greater than 0. 1 we are taking here. So log x to the base e is greater than minus 1. If you want to get x value, x is greater than e power minus 1, x is greater than 1 by e. So x is greater than 1 by e means we have that x is greater than a. That implies x is belongs to a to infinity. So x belongs to 1 by e to infinity. So in this interval the function is increasing. Therefore f of x is increasing. F of x is increasing in the interval 1 by e comma infinity. We will go to the next question, dear students. See, dear students, you have some doubt regarding this. Sir, you said that it is strictly increasing. Increasing means you have to get it less than or equal to 0. But whenever increasing, decreasing here is given, you can take always strictly increasing, decreasing. Even here also, you can write strictly also nothing will happen. Why? Because in the textbook Telugu Academy, they are giving in this way. So you can take wherever it is increasing, decreasing is given, you can take as strictly increasing, strictly decreasing. Simply here you can take strictly increasing. Why? Because strictly increasing only you can take as greater than 0, less than 0. Otherwise, in the question itself you can change here. Increasing, decreasing means strictly increasing, strictly decreasing. You can go to the next question. Yeah, the next question. This question already asked in public examination for 4 marks. Previously they asked. You keep concentration on this question, dear students. Determine the intervals in which the function f of x equal to 2 by x minus 1 plus 18x for all x belongs to r minus 0 is strictly increasing or strictly decreasing. They are asking to calculate both the intervals. So now first consider the function. After that find the derivative of the function. So first given function f of x is equal to 2 by x minus 1 plus 18x. Differentiate with respect to x. F of x derivative is f dash of x. What is d by dx of 1 by x? Minus 1 by x squared. See here, 1 by x minus 1 is there. You have to know about the derivatives of the reciprocal function. d by dx of 1 by x is minus 1 by x squared. After that x coefficient is other than 1, again you have to differentiate. But by luckily here x minus 1 x derivative x coefficient is 1. No need to do that. So 2 into d by dx of 1 by x minus 1 is minus 1 by x minus 1 whole square plus 18x derivative is 18. This is the derivative of f of x. Now f dash of x value we got it. F dash of x is equal to minus 2 by x minus 1 whole square plus 18. Now you can simplify. Yeah, now simplification. F dash of x is equal to, here take LCM, x minus 1 whole square is the LCM. So minus 2 into 2 plus 18 times of x minus 1 whole square. After that, f dash of x is equal to, here minus 2 take common, 2, only 2 take common. Minus 1 plus 9 into x minus 1 whole square by x minus 1 whole square. This is the value of f dash of x. So 2 by x minus 1 whole square you can take here. Now come to the intervals. F of x is strictly increasing. Strictly increasing. Then f dash of x is greater than 0. So what is f dash of x? This value you know. So that is 2 by x minus 1 whole square into minus 1 plus 9 into x minus 1 whole square is greater than 0. So 2 by x minus 1 whole square completely we can take this sign. So now the remaining values 9 into x minus 1 whole square minus 1 is greater than 0. So now what I am doing is 9 into x square minus 2x plus 1 minus 1 is greater than 0, making a quadratic equation here. 9x square minus 18x plus 9 minus 1. So 9x square minus 18x plus 8 is greater than 0. So here 72 will be there now. So how to write 18x? So 9x square, 18 can be written as 12 and 6 minus 6x minus 12x plus 8 is greater than 0. Factorization. Actually we can do like this also. 9 into x minus 1 whole square equal to 1, x minus 1 whole square equal to greater than 1 by 9. Like this it will come, but it is, I want to convert it in form of x minus alpha and x minus beta. That is the reason I am proceeding in this way. You remember that? Even if you want, you can go like this also, you can get it. Otherwise, another possibility just I am showing. According to your convenience, you can do that. From here, you can do like this also. 9 into x minus 1 whole square is greater than 1. X minus 1 whole square is greater than 1 by 9. And x minus 1 is greater than plus or minus 1 by 3. So, based on the cases, you can go that. But here I am converting in that form. From these two 3x take common, 3x into 3x minus 2 minus, here 4 take out common, 3x minus 2 is greater than 0. So 3x minus 2 into 3x minus 4 is greater than 0. 3 take common here, x minus 2 by 3. 3 take common here, x minus 4 by 3 is greater than 0. 2 by 3 means here 0.7, 4 by 3 is 1.7. Therefore, this is opposite beta. 3 into 3, 9, we can take this side. So, it will become x minus 2 by 3 into x minus 4 by 3 is greater than 0. It is in the form of, in the previous question I said that x minus alpha into x minus beta is greater than 0 and alpha is less than beta. X belongs to open interval of minus infinity to alpha union beta to infinity. In this interval, the function is increasing. Therefore, x belongs to minus infinity to 2 by 3 union 4 by 3 to infinity. In this interval, f of x is increasing. In this interval, f of x is f of x is strictly increasing. Now f of x is second one, strictly decreasing. Then f dash of x is less than 0. What is f dash of x? This value directly you can take. Instead of writing this, you can take this value is equal to this one only now. That is x minus 2 by 3 into x minus 4 by 3 is less than 0. So now again we have formula. X minus alpha into x minus beta is less than 0 when alpha is less than beta. Then x belongs to open interval of alpha comma beta. So that implies that x belongs to 2 by 3 comma 4 by 3. In this interval, the function is in this interval, f of x is strictly decreasing. This is the way you have to do the problems. We will move to the next question, dear students. The next question is very important for 2 marks. If 0 is less than or equal to x is less than or equal to pi by 2, then show that x is greater than or equal to sin x. This type of questions which are very important for 2 marks. See here, we are going to apply here increasing definition. First, given function, how to write the given function? X is greater than or equal to sin x is they are asking to show now. So, f of x we have to consider this sin x, we can take this side x minus sin x, no? Let first given condition you write it, given that 0 is less than or equal to x is less than or equal to pi by 2. And let the function, let f of x be x minus sin x. X sin x we are taking this side, therefore x minus sin x is the function. After that, here 0 is less than or equal to x is there. So to apply increasing or decreasing, suppose if it is increasing, if you take x1 is less than x2, that implies that f of x1 is less than or equal to f of x2 for all x1 comma x2 belongs to R. R means interval. Otherwise, you can write as interval. Interval means here according to this interval, x belongs to closed interval of 0 to pi by 2. So now what I am doing is x1, x2 values are there. This is the definition. So come to here, 0 and x I am taking. This is x1, this is x2. Now considering let 0 is less than x, that implies that f of 0 is less than or equal to f of x by definition of increasing function. So I want to calculate f of 0 value. So f of x is equal to x minus sin x. So f of 0 is equal to 0 minus sin 0. Sin 0 is 0. So f of 0 equal to 0. So now 0 is less than or equal to f of x means what? X minus sin x. So that implies minus sin x I am taking into this sign. So it will become sin x is less than or equal to x. But they are asking to prove x is greater than or equal to sin x. No? If you interchange these two, x is greater than or equal to sin x. Hence proved. Hence the result. We'll move to the next question. The next question. Show that tan x is greater than x for all x belongs to closed interval of 0, open pi by 2. So first given that x belongs to closed 0, open pi by 2. That meaning is 0 is less than or equal to x is less than pi by 2. Closed 0, open pi by 2. So now given function, let function f of x equal to tan x is greater than x is given now. So I am considering tan x minus x, that x I am taking here. So f of x is tan x minus x. Like in previous question, to prove this result, inequality tan x is greater than x, we need to consider the increasing function here. Tan x is greater than x. 0 is less than or equal to x is there. Now let 0 is less than x. That implies by definition of increasing function, this is x1, this is x2. That implies that f of 0 is less than or equal to f of x. Now calculate f of 0. F of x is equal to tan x minus x. So f of 0 equal to tan 0 minus 0. So tan 0 0 anyway 0 minus 0. So 0. So now f of 0 value is 0 is less than or equal to f of x is what? Here strictly increasing function we can take according to tan x is greater than x they are asking now. So strictly increasing definition we can take. Even here also f of 0 is less than f of x. 0 is less than f of x. So that implies 0 is less than f of x means tan x minus x. That minus x we can take this side. So x is less than tan x. What is the meaning of x is less than tan x? Tan x is greater than x obviously. So hence proved. This is the way you have to prove that. Show that tan x is greater than x. In which interval it is 0 is less than x means obviously 0 is less than or equal to x is less than pi by 2. We will move to the next question. The next question, show that x plus 1 by x is increasing in closed one, open, infinity. First, given function f of x is equal to x plus 1 by x and condition is given closed interval of 1 comma infinity. In this interval it is increasing. So under x belongs to that giving that closed one, open, infinity. That meaning is 1 is less than or equal to x is less than infinity. So x may equal to 1 or x is less than infinity. So now to calculate, to show that the function is increasing, we need to differentiate with respect to x. F of x derivative is f dash of x. D by dx of x is 1. D by dx of 1 by x is minus 1 by x square. Now, after taking LCM and all, x square here, x square minus 1, which is f dash of x. They are asking to prove it is increasing. So, f of x is increasing. Then f dash of x is greater than or equal to 0. F dash of x means this only. So, x square minus 1 divided by x square is greater than or equal to 0. That implies that x square minus 1 is greater than or equal to 0. So, x square minus 1 can be written as x plus 1 into x minus 1 is greater than or equal to 0. So, that also can be written as x minus of minus 1 into x minus 1 is greater than or equal to 0. It is looking like x minus alpha into x minus beta is greater than or equal to 0 when alpha is less than beta. Here minus 1 is less than 1. So we have x belongs to minus open interval of minus infinity to closed alpha union closed beta to infinity. So that implies x belongs to open interval of minus infinity to minus 1 minus closed 1 union closed 1 to infinity. But they are asking to prove the function is increasing. This function is defining for only closed 1 to infinity. If you take any value of x in between this, in this interval, the function is not at all increasing. So, x belongs to closed 1 comma infinity. In this interval, the function f of x is increasing. If you take any value in between in this interval, the function is not at all greater than or equal to 0. That is the reason we will take only closed 1 to infinity. Exactly, if you want the figure, that means real number line, this is minus 1, 0, plus 1 and infinity minus infinity. So according to this, open minus infinity, closed minus 1 and closed 1 to open infinity. If we take any value in between this interval, the function is need not be increasing. So that is the reason, if you take any value in between these closed 1 to open infinity, in this it is increasing. So hence the function is increasing in this interval closed 1 to infinity. Yeah, dear students, this is one of the important type and a different question based on increasing decreasing functions. How they are asking to show that x by 1 plus x is less than log of 1 plus x is less than x. Simply they are asking like this. For this condition x is greater than 0. So first of all there is no f of x here. There is no g of x. So what we have to do is here from the given condition, from first two inequality, from these two inequalities, you can make as function. Let f of x is equal to x divided by 1 plus x, log of 1 plus x we are taking this side, so minus log of 1 plus x. This is the way you have to consider f of x. After getting the value of f of x, we need to differentiate. Differentiate with respect to x. F of x derivative is f dash of x. U by v formula, x by 1 plus x. So 1 plus x whole square. V means 1 plus x into d by dx of x is 1 minus x into d by dx of 1 plus x is 1 minus d by dx of log of 1 plus x is 1 by 1 plus x. So here minus x plus x we cancel, f dash of x is equal to 1 plus x minus x divided by 1 plus x whole square minus 1 by 1 plus x. So taking LCM, f dash of x is equal to 1 plus x whole square is the LCM. So 1 minus 1 plus x cancel means 1 more 1 plus x is there. 1 plus x into minus 1 is minus 1 minus x. These two will be cancelled, which is equal to f dash of x is equal to minus x by 1 plus x whole square. Here x is greater than 0. What I am doing is f of x is increasing. F of x is increasing. Then f dash of x is greater than or equal to 0. Greater than 0. I am taking here strictly because all less only this is given now. So f dash of x means this value only no. Minus x by 1 plus x whole square is greater than 0. The remaining minus x is greater than 0. If you remove this inequality, sign change. So here sign change, x is less than. If you remove the sign, the inequality will change, x is less than 0. So x is less than 0. But condition is x is greater than 0 is there. So what we have to do? F of x is decreasing, you take. So that time f of x is decreasing. Then f dash of x is less than 0. F dash of x means obvious, minus x by 1 plus x whole square is less than 0. So minus x is less than 0. If you remove minus symbol, the inequality will change, x is greater than 0. This is our required condition. Even this also I am going to use. See here, we proved that x is greater than 0. For all x is greater than 0, we have taken. X is greater than 0 means meaning is what? X is greater than 0, that implies that 0 is less than x only. 0 is less than x. So, by definition of increasing, 0 is less than x. Otherwise, x is greater than 0, we have no decreasing. What is the definition of decreasing? 0 is less than x. That implies that f of 0 is greater than f of x. This is decreasing function definition. Either increasing or decreasing, anything it will come answer. F of 0 is greater than f of x. F of 0 we need to calculate. F of x value is this one. So f of 0 calculate. F of 0 equal to, wherever x is there, 0 by anything is 0. Minus log 1. What is log 1? Log 1 is also 0. So ultimately f of 0 value is 0. So now come to this condition. 0 is less than x. Why we are writing 0 is less than x? X is greater than 0. That implies f of x, f of 0 is greater than f of x. What is f of 0? 0 is greater than, what is f of x? This one. So x by 1 plus x minus log of 1 plus x. This minus log of 1 plus x I am taking here. So log of 1 plus x is greater than x by 1 plus x. Log of 1 plus x is greater than x by 1 by x means if you interchange these two, inequality will be again less. So x by 1 plus x is less than log of 1 plus x. Put it in equation number 1. After that, again you have to consider these two. Let g of x is equal to another function I am taking. log of 1 plus x minus x. Again differentiate with respect to x. So g dash of x is equal to log of 1 plus x, derivative is 1 by 1 plus x minus x, derivative is 1. So if you simplify, g dash of x is equal to 1 plus x is the LCM, 1 minus 1 minus 1 minus x. So minus 1 minus x cancel, minus cancel. So g dash of x is equal to minus x by 1 plus x. After that, g dash of x equal to minus x by 1 plus x is there. No? Again, x is greater than 0, it is there. So g of x is increasing or decreasing. Here, second case we got it now, x is less than, here also we will do that. Decreasing. G of x is decreasing means g dash of x is less than 0. What is g dash of x? Minus x divided by 1 plus x is less than 0. So cross multiply, minus x is less than 0. If you remove minus here, inequality will change. So x is greater than 0. We got it, x is greater than 0, we proved. But we need to prove that result. So x is greater than 0 means obviously 0 is less than x. So now take the definition of decreasing. x1 is less than x2, that implies f of x1 is greater than, f of x1 means here f of 0 is greater than f of x. Again we have to apply this definition. If you do not remember this one, again I am writing the formula. x1 is less than x2, that implies f of x1 is greater than f of x2 for all x1 comma x2 belongs to I interval. This is the definition of decreasing. So f of 0, what is f of 0? Not here f, here g. We have taken here g of x now. So g of 0 is greater than g of x. What is g of 0? G of x value we got it here. So here only I am calculating g of x, g of 0. So in place of x substitute 0. So log 1 plus 0 is log 1 minus 0. Log 1 is 0. 0 minus 0 is 0. Ultimately g of 0 is 0. So g of 0 is 0 greater than g of x is what? G of x is equal to log of 1 plus x minus x. Log of 1 plus x minus x. So minus x we can take this sign. X is greater than log of 1 plus x. If you interchange these two, inequality will change again. It implies log of 1 plus x is less than x. It is equation number 2. From 1 and 2. This is equation number 1. This is equation number 2. From 1 and 2 we conclude that x by 1 plus x is less than log of 1 plus x. Log of 1 plus x which is also less than x. In these two possibilities, in which case we got it? X is greater than 0. So for all x is greater than 0. Hence proved. All the questions of this type we can do in that way. There is no other alternate. The next question, this question already they asked in the intermediate board for 4 marks question. At what points the slopes of the tangents to the curve y equal to x cube by 6 minus 3x square by 2 plus 11x by 2 plus 12 increase? At what points, that means at what intervals, the slope of the tangent to the curve. Slope of the curve is denoted by dy by dx. Generally slope is denoted by what? M. So first we have to consider the given curve and find the dy by dx value. So first given curve y is equal to x cube by 6 minus 3x square by 2 plus 11x by 2 plus 12. Now differentiate with respect to x to get the slopes of the points, slope of the tangents. So y derivative is dy by dx, which is equal to 1 by 6 constant, x cube derivative is 3x square. So 3x square divided by 6 minus 3 by 2 constant, x square derivative is 2x plus 11 by 2 constant, x derivative is 1 and 12 constant whose derivative is 0. So now therefore dy by dx, it is denoted by m. m into dy by dx equal to 3 1s are 3 2s are. So x square by 2, 2 to get cancelled. It will become minus 3x plus 11 by 2. This is the slope. What they are asking, at what point the slopes of tangents of this curve is increasing. Given that the slope of the curve is slope of the curve or slope of the tangent. Given that the slope of tangent to the curve increases, then whenever function is increasing whose derivative is greater than 0, f dash of x is greater than or equal to 0. Similarly, whenever the slope of the tangent of the curve is increases, d by dx of m is greater than or equal to 0. Keep in mind, dear students, increases. You can take strictly increasing also, you can take dm by dx. Why? Because they are asking to find intervals. So d by dx of m, what is m value? This value. This is value m, we got it. Substitute in this, that is. So d by dx of, what is m here? X squared by 2 minus 3x plus 11 by 2 is greater than 0. So differentiate, normal differentiate. D by dx of x squared 2x by 2 minus 3x. D by dx of 3x is 3. Constant derivative 0 is greater than 0. To get cancelled, it implies that x minus 3 is greater than 0. X minus 3 greater than 0 means x is greater than 3. In this interval, 0, 3, infinity, minus infinity. X is greater than 3 means from here to here. In this interval, the function means the slope of the curve is increasing. In this interval, it is increasing. They are asking only increasing means we will discuss about only increasing. Therefore, x belongs to open interval of 3 to infinity. In this interval, the function is increasing. In this interval, the slope of the tangent to the curve increases. We'll move to the next question. Suppose, dear students, if they will ask instead of increasing, decreasing, the rest of the part from here to here, it is decreasing. In this interval, it is decreasing. That's all. That means minus infinity to 3. Open interval of minus infinity to 3, it is decreasing. In open interval of 3 to infinity, it is increasing. We will move to the next one. Yeah. The next question, this is also they are asked in public examinations. Find the intervals in which the function f of x equal to x cube minus 3x squared plus 4 is strictly increasing. Strictly increasing means f of x is greater than 0. So first, given function f of x is equal to x cube minus 3x squared plus 4. So to find the intervals, whether it is increasing or decreasing, we need to calculate the derivative. So differentiate with respect to x to the given function. F dash of x is equal to 3x squared, x cube derivative is 3x squared minus 3 into x squared derivative is 2x and constant derivative is 0. So f dash of x is equal to 3x squared minus 6x. After that, f of x is strictly increasing. Then f dash of x is greater than 0. That is, what is f dash of x? 3x squared minus 6x is greater than 0. Take common 3x into x minus 6, sorry, x minus 2 is greater than 0. 3 we can take this side. So x into x minus 2 is greater than 0. Sir, why you are not taking x? The doubt will arise. See here, it is a quadratic equation, quadratic expression. We have two values. So x can be written as x minus 0 into x minus 2 is greater than 0. So in the real number line, 0 to infinity and minus infinity. Here 0 and 2 values are there. Whenever x minus alpha, here I am giving the formula from the functions. X minus alpha into x minus beta is greater than 0 when alpha is less than beta. The value of x lies between minus infinity to alpha union beta to infinity. In this interval, the function is increasing. So x belongs to open interval of minus infinity to 0 union 2 to infinity. In this interval, the function is f of x is strictly increasing. So from here to here, union, from here to here. In these intervals, the function is increasing. Increasing means I am showing like this. Same one, they did not ask, but this also you can calculate. F of x is strictly decreasing. Then f dash of x is less than 0. Directly I am writing this one, f dash of x, this value we are taking. So, x minus 0 into x minus 2 is less than 0. Again we have formula. X minus alpha into x minus beta is less than 0. When alpha is less than beta, x belongs to open interval of alpha comma beta. That means, in this interval the function is decreasing. You remember, in these two increasing, in this interval it is decreasing in this. So x belongs to open interval of 0 comma 2. In this interval the function is decreasing. In this interval, f of x is strictly decreasing. Thank you dear students for watching my channel. If you have any doubts regarding this, you can write in my comment box. I will help you. And whichever the required concepts, I am ready to help you. Thank you all, whether it is Andhra Pradesh, Intermediate or MSET or JEE or Telangana MSET or JEE students. You can approach me. I am ready to help. In my free time, I am making videos for the students' welfare. Thank you all.